So we talked about equivalent expressions in the previous set of problems, and now we'll talk about equivalent equations. So think back to the idea of equivalence on the previous page, as we will now talk about what makes equations equivalent. Remember, equations always have equal signs, right? So now we see some equations down below. And the questions in 1 and 2 are the same. Do you think that these two equations are equivalent? So I want you to maybe pause the video right here and see if you can answer that question to yourself. And then unpause it and we will talk. All right, so what does it mean to have two equations equivalent? All right, so it must be related to something with what we talked about on the previous page, maybe. Equivalent expressions have the same answer. And when you simplify two equivalent expressions, they turn out to be the same. So what do we do with equations typically? At least in the first few sections of this unit, we have been doing a lot of solving equations. All right? In other words, we're trying to get the value of x. So let's look at the first two and think about solving these. Something plus 2 equals 8. These are both equations that you probably can solve in your head. What plus 2 equals 8? We know 6 plus 2 equals 8, right? And if we're going through the algebraic operations to show that, we will undo the addition of 2 by subtracting 2 from both sides. So 2 minus 2 is 0, so we just have 1x left, and 8 minus 2 is 6. So x equals 6, of course we knew that. And then the second equation, something plus 4 is equal to 20. What is that something? Hopefully you are also doing this one maybe in your head, saying, well, 16 plus 4 is 20. And you would be correct on that. If we're showing algebraically how we get that, we'll get x by itself by undoing the addition by subtracting 4. 4 minus 4 is 0. We do the same thing to both sides of the equation. 20 minus 4 is 16. Okay, so what do you think about that? Do you think those two equations are equivalent? All right, let's not quite answer that yet, I guess. And you might have an answer to that. Hopefully you do, actually. But let's do the number 2 equations. These ones are maybe a couple steps. So 2 times something minus 10 is equal to 8. All right, so remember, well, we usually undo any addition or subtraction first in a two-step equation. So we have a minus 10, so we will add 10 to both sides. Negative 10 plus 10 is 0, bring down 2x. 8 plus 10 is 18. Remember, this is 2 times x. In other words, 2 times something is 18. Probably do that in your head, maybe. But we will undo this multiplication now by its inverse, or undoing operation, which is division. So 2 divided by 2 is 1, or 1x, or just x. And 18 divided by 2 is 9. So the solution is x equals 9. Let's do that same thing in the second equation. This should look a little bit familiar because really we had something like this in the first equation. 2 times something is 18, which we know if we undo by dividing both sides by 2, or if we just do that in our head, we know x is equal to 9. Okay, so which of the two sets of equations do you think are equivalent? Hopefully you're saying the equations in set 2 are equivalent. Yes, because they have the same solution. Of x equals 9, I should say. All right, versus first one where we might say no, they don't have the same solution. Okay, and hopefully you also noticed that in the process here, when we were solving, we actually ended up with 2x equals 18, which is what we had over here. And that will often happen when you are seeing equivalent equations that might not start off looking the same. They might not start off looking equivalent, but once we start simplifying it, or once we start to solve it and create equivalent equations, because we do the same operation to both sides of the equation, we can see at some point in the process we end up with that same equation there. So that also shows that the equations are equivalent if somewhere in the work you end up with an equation that you have on the other one. Okay, so let's read this below. When we solve equations, we talk about undoing numbers from both sides of the equation, which keeps our equation balanced. So I often talk about that too. When we do the same thing to both sides of the equation, we keep things balanced. Just like if you had a scale, maybe at the grocery store, they used to have these. I think they still do, but if you put something on one side of the scale to keep things balanced, you have to put the same weight on the other side of the scale if you're going to keep things balanced. It's also correct to say that when we undo from both sides, each step of the process gives us an equivalent equation, since the revised equation will have the same solution as the original. So that's what I was saying here. Each step of the process here, notice we still have an equation. 2x equals 18 is still an equation, even though it looks different than the original. But it's an equivalent equation because it has the same solution as the original equation. You can see that we ended up with the same solution over here because we have an equivalent equation over here. All right, so when we solve equations, what we're really doing is throughout the whole process creating a bunch of equivalent equations that look different but will have the same solution. So when we solve this one, we're going to do a little bit more challenging solving equations now that involve maybe just a couple more steps than we have. But the first thing we would typically do in the equation like this is the distributive property. So 4 times x is 4x, 4 times 2 is 8. All right, and then we go through our undoing solving steps, which normally means that we undo any subtraction or addition first. So we'll undo the adding of 8. Remember, trying to get x by itself, because 4 times something plus 8 is 10. 4 times something plus 2 is equal to 10 at the beginning. So we'll undo from both sides of the equation, bring down what's left. 8 minus 8 is 0, so we'll bring down 4x. 10 minus 8 is 2. All right, so 4 times something is equal to 2. Okay, so that something must be a fraction because it's getting smaller. And so if we divide to undo this multiplication, 4 times x, if we divide both sides by 4, 4 divided by 4 is 1, so 1x, or just x. 2 divided by 4 is either going to be written as a decimal, 0.5, 5/10, or maybe you can reduce the fraction and you'd state it as just 1/2. 2/4 as a reduced fraction is 1/2. And throughout this process here, we have created equivalent equations. So here's our original. Here is a modified equation, but is equivalent because we do some solving steps. We undo the same thing from both sides. So this 4x equals 2 is equivalent to 4x plus 8 equals 10 is equivalent to the original. And so throughout the process, we've created equivalent equations and end up with a solution. All right, let's do this next one. This next one doesn't have any distributive property, but it does have a couple of like terms on the same side of the equation that we can put together. So before we start undoing anything, let's just add these together. 2x plus 3x would be 5x minus 6 equals 29. And now we'll undo like we did on the previous problems. So we'll undo by adding 6 to both sides. Bring down what's left. 5x equals 29 plus 6 is 35. And then 5 times x. So we'll undo by dividing. 5 times what is equal to 35? Maybe you can do that in your head. But we'll divide both sides by 5. And 35 divided by 5 is 7. And once again, throughout this problem, we've created equivalent equations. So here's the original. Here's a little bit more simplified equivalent equation. Add 6 to both sides. 5x plus 35 is equivalent. And we eventually end up with x equals 7. One more. All right, draw a line down here. So this has both of those ideas. So normally, when we solve, you might want to start off with thinking about doing the distributive property and then combine like terms. and then undo any addition, subtraction, and then undo multiplication and division. So in this case, we'll do the distributive property here first. That 5 is in front of the parentheses, x minus 8. So let's rewrite what we have. Negative 3x. 5 times x is 5x. 5 times a minus 8 would be a minus 40 equals 12. And now we'll combine like terms. So negative 3x plus 5x, putting those together, we get positive 2x minus 40 is equal to 12. And now we can do our undoing step. So undo any addition or subtraction, we'll add 40 to both sides. So 2x is equal to 52. Then we can divide both sides by 2. X is equal to 26. All right, so we have talked about equivalent equations, and we've also done some practice then solving equations, keeping in mind that the reason why solving an equation works is that we are creating equivalent